C'est bizarre. All right. Good morning, everybody, to another session. Let's check the schedule. Am I missing something? If it is, no, we are talking about the next section, length measurement. Length measurement. Now, admittedly, for the majority of you, the next few sessions, the topic is not overly complicated, familiar, yet important to be aware of these things that perhaps you never think about, especially when it comes to length measurement units. When you teach that, you might think it's a given, and because you're so used to measuring lengths and distances, but to a student learning that for the first time, of course, it's brand new information and you don't want to take that for granted. Can't see the screen. Okay. Check. I did start the screen. Yeah, accidentally. Good. Everything should be better now, I hope. Okay. Okay. So to make things a little bit more interesting, we will use different length measurements, but the idea of measuring distance and length is the same across any unit. I have length, be it short or a long distance that I travel, that I want to convey the quantity in an accurate way. If I just say, "Oh, I walked my dog 5 what?" That has no meaning until I associate some unit, some measurement to compare that to. If I say I walked my dog 5 miles, now you can compare that to a standard 1 mile unit, which you have a sense for, and then my distance traveled is 5 times that unit. Now kids start with measuring a length by random things like a unit pencil length, and then they arrange the pencils. But the idea of having a unit of measurement to compare my lengths and distances to is the same. The difference is just that my unit might be different depending on the scale that I'm working in. So, historically speaking, the I guess one of the first, oh, my writing just stopped there. One of the first units was a foot. They measured the king's foot, and that was how they would refer to lengths. That it's maybe 5 feet, 5 times as long as the king's foot. But of course, soon they would realize that maybe with the next generation, the next king has a different size foot. And now what I used to say a generation ago doesn't carry the exact same meaning anymore. So they soon had to standardize the meaning of this 1 foot unit. But regardless, uh, this was one of the first, I suppose. And because these things slowly developed over time, the English system of measurement was is a little unintuitive because slowly over time they added more units because if I travel a very long distance, I don't want to measure that in feet. I want to have a unit that's a little bit more efficient to use so that the number doesn't get too big. So they introduced the concept of a yard, and 1 yard is equivalent to 3 feet. That's an F. So that now if I run a little distance, maybe it could be a very large number of feet, but not as many yards. So it's easier to work with. And then when I travel even longer distances, let me just move my stuff around here a little bit. So if I travel longer distances, it could be many, many, many yards, and that's not quite as efficient to use. So they introduced the unit of a mile. And for reasons I don't actually know, 1 mile is equivalent to 1,760 yards. Why? Well, I don't really know, to be honest with you. And it's interesting, historically speaking, to investigate where these conversion amounts came from, but that's not really our focus. So depending on the scale that I'm um, thinking or working with, a different unit might be just more comfortable to use. I can travel to the other side of the country and I can talk about the number of feet that I traveled, but it's not a very appropriate unit to use. I would rather talk about miles in this system. And then the same if I measure something much shorter than a foot, talking about fractions of feet might be a little bit cumbersome to use. So the idea of an inch was introduced, and I'll do it like this: 12 inches fit into 1 foot, or corresponds to 1 foot. So then if I'm measuring um, the size of my hand, for example, instead of talking about a fraction of a foot, I can talk about uh, a whole number of inches, and it's just more convenient to convey information. Okay. So this slowly developed over time, and I mean it's still used in I don't know how many countries, but definitely some. So if we now look at uh, exercise, I'm going to do it a little backwards, but compared to the book. Exercise 11.2. I'm going to do that one first. It says, and this is going to be my basic question: convert the following lengths or distances: 50 feet into yards, 2 yards into inches, the number of inches into miles, and any combination of those within this English system. Whoopsie. Let's call this the English system. Right. So let's do that first. Now, when I convert units of length or other units, there certainly are different ways to do that, and it depends on your experience, depends on your comfort level, and of course, I don't know that, and it depends on the student that you might be teaching as well. So I'll go 2 ways. They are essentially the same. One is just a compact version of the other. I want to give you at least a couple of options, because whenever you do something sort of in a short, efficient way, it doesn't show. It's not necessarily a way you can teach. So if you are comfortable converting units in a certain way, you can't necessarily use that way to teach little Timmy for the first time how to do that. So it's good to have some options where the level of detail is scaled a little bit. So first, I'll do the detailed one. First, let's review. Man, my writing is a little laggy and I don't know why. Let's review ratio equations. At best, my writing is messy. So when there's lag between what I see and what I do, that's even going to be worse. Now, if you've done Math 142, you might remember the word ratio equation. If you haven't, well, now you're going to learn ratio equation. Simply speaking, it is fraction equal to a fraction. And somewhere is my unknown in the equation. Now, let's look at number one. Yeah, I've got some lag and I don't know why. That's my excuse for any messy writing, of course. Let's look at question number one. I want to know 50 feet will correspond to how many yards? Now, it can be a very simple one where you can say, well, of course, I'm just going to do this, this, and this. Looking at my table up here. But let's suppose, I want to handle this in general, when it's obvious to me and when it's not obvious to me. What do I do? Because to little Timmy for the first time, it's never going to be obvious, right? You can't ever teach with the approach of, well, obviously just do this to me. What's wrong with you? Why can't you see that? That is the worst thing ever. So it's very much in this topic, in these next few topics, a matter of sort of experience makes a huge, huge difference. So this is the sort of the conversion pair that has one of the unknowns. One of the sides is unknown. So this is what I sort of want based on the question. And then I need some sort of reference pair, I'll call it, where I know that 3 feet corresponds to 1 yard, according to my table that I would have in front of me. Here, I look up, well, which are the units that I'm interested in here? Yards and feet. Okay, so this is my reference pair that I would remember, that I can look up, and so on. Again, this is the very detailed version. It's not the only one. There's a difference between teaching to someone that has never seen this before and doesn't know how to go through this and navigate this, and the difference between that and doing it yourself, just quickly getting the answer. Showing some work, but trying to be efficient. There's a difference between those two. Okay, so now I have things set up here. I'm just going to copy this over for no reason whatsoever other than to not erase what I have there. Just going to copy it over. Whenever you see bad and choppy writing, it's because it seems to be stuttering on my end for some reason. I don't know why. My computer needs a restart, I think. Every now and then, just a little restart does a computer some good. Okay, so what I'm going to do now is going to make some fractions here. Then I'm going to erase these arrows. Double arrows. And then I'm going to put an equal sign between them. And there's my ratio equation, which you can argue that the ratio of feet to feet has to be the same ratio of yards to yards because it's the same quantity. Now you could swap these around in a way, but this is just how I set it up, so it doesn't really matter. Now, how do I solve a ratio equation? Whenever I have a fraction equal to a fraction, I can cross multiply. This does not mean cross out the equal sign, it just gives me direction. So I'll pick the pair that has the variable, so 3 times question mark will equal 50 times 1 in this case, but it doesn't always have to be a 1, right? Many things. And then how do I isolate the question mark? I divide by 3 on both sides. So question mark equals 50 times 1 over 3. And then I can calculate that. Let's do it in the chat to see something. See if MathBot is awake. That's unfortunately going to have some repeated decimals. I'll go 2 decimals, 16.67. And then I can go back up here and fill it in and say 50 yards. I should probably write out a sentence here. 50 feet, rather, corresponds to 16.67 yards. So whenever someone is not clear on understanding the reasoning behind how we get to that 16.67. The ratio equation is a nice systematic way that'll always work, regardless of how simple or how complicated the conversion pair and the reference pair may be. I know some of you might say, well, of course I divided by 3. It's obvious. It's a matter of perspective and a matter of experience. And I don't necessarily want to assume that my audience and everyone in the audience feels that it is obvious. Audience, whether it's at elementary school or somewhere else. Now, nothing wrong with this. Have it in your back pocket whenever you're teaching and something gets confusing. You can do this or a variation of this level of detail. And this is not the only way, of course. Or I can do it a little bit shorter. This is more the sort of the physics route, just a little bit more concise, where I simply need to keep track of the units. I could say, well, 50 feet is what I have to start with. I need to convert that to a certain number of yards. Is that right? Do I have it backwards? No, 50 feet to yards. Okay. So what I'm going to do, let's just get rid of this arrow part. I have to sort of convert the units to end up in yards. So I'm going to make a fraction here, and this fraction is going to be my reference pair, feet to yards. I'm going to put feet in the bottom and yards in the top because when I simplify the units, remember this is over 1, fraction, a top and a bottom can cancel, the feet can cancel with those feet, and I'll end up with yards. So the unit is correct. This reference pair is going to be 1 yard and 3 feet, which is essentially the same distance, the same length, right? So I'm not changing the original length of 50 feet because 1 yard is exactly the same as 3 feet. This is sort of like multiplying by 1. I'm not changing the original quantity. I'm simply converting it to a different unit. So then you see here the feet cancels with this feet as if they're numbers. I can sort of simplify them to see that my end unit is what it should be, even though they're not numbers, but they sort of work the same in simplification. And then I have 50 times 1 over 3, and again here I get 50 times 1 over 3, which is of course the same. So it's just a slightly more compact version of this. It is exactly the same thing, but I didn't have to set up an equation, didn't have to go this long detailed route if I don't have to. It's simply a matter of multiplying by a fancy 1. This is a fancy 1, I'll say. Write it fancy. Because 1 yard and 3 feet, they're the same length. So they sort of cancel each other. But this allows me to convert the unit. So let's practice this maybe a little more because it has a nice middle ground between showing some work and not getting bogged down with equations and stuff. Let's see, what was the next one? Next one was 2 yards into inches. So I start with 2 yards. I'm going to pick a conversion pair that will allow me to end up in inches. It's going to be, oops, let's get rid of this for a second. Let me just make a plan first. Make a plan first. I'm sort of at the mercy of my table of unit conversions, of reference pairs up here. And there's no immediate conversion in this that I have that takes me from yards directly to inches. I'm going to have to make a little path here. I can go yards to feet and then feet to inches. So I can go yards to feet then feet to inches. That's going to get me to my inches. Okay, let me just move this so I have enough space. So the first goal is to convert the yards to feet. So I'm going to put yards in the bottom and feet at the top for my reference pair, which is 1 yard is equivalent to 3 feet. And because those lengths are equivalent, I haven't changed the quantity. Just making it look different. It hasn't actually changed. So currently the yards cancel and I'm currently in feet. That's not my end goal. My end goal is to be in inches. So then I'm currently in feet. I'm going to multiply with a reference pair that has feet and inches. I'm going to put feet at the bottom to cancel with my existing unit and inches at the top. So now my answer will be in inches. What is the conversion there? 1 foot, 12 inches. And this gets me then the calculation, 2 times 3 times 12 divided by 1 divided by 1. That should be 72. So this is definitely more efficient in that I can sort of string them all together to systematically get to the unit I want if my table doesn't allow me to do it directly. Now in a test question, we want to see if you can chain them together. So the table that I give you is the only table you are allowed to use. If there is no direct conversion between yards and inches, you have to make the chain. This is the only table, for example, that you are allowed to use. Because if you use the internet, you can do pretty much any conversion immediately, right? That shows no insight or knowledge whatsoever. Letting Google do it for me does not make me a better person. All right, so this is a nice middle ground. You're showing some work, you're showing your steps, you're converting your units, you're doing a calculation, but it doesn't get bogged down in equations when they're perhaps not necessary. But just be aware that I might not be able to teach this. It depends on my audience, right? If I were to do high school science, maybe this would be okay. If I'm doing conversions of units for the first time in elementary school, I probably won't go to this. I'll try and gauge the student first. And then if they seem quite competent, maybe then. It depends on your audience. Which is what makes teaching so difficult. Within a classroom, there is such a wide variety of skills and backgrounds and everything that you can't sort of do one broad stroke to cover everyone. It's impossible. It's not effective teaching. So now I have 235 inches that I want to get to miles. Let's make a plan first. So I'm starting in inches. Ugh. Let me go to my table. And let's suppose this is the only table of conversions that you are allowed to use. To find a path here. Inches to feet for sure. It's the only option I have. Then feet to yards. Then yards to miles. Okay, it's not a big deal. Doesn't really matter how long the chain is. I'm just going to multiply by a reference pair here. My first reference pair is going to have to be inches and feet. Which one goes where? Inches at the bottom, feet at the top. So the inches unit can cancel because this is over 1, right? It's at the top. And the conversion there is 1 foot, 12 inches. Now I'm currently in feet. Feet. Now I have to convert that to yards. I'll go feet at the bottom, yards at the top. 1 yard, 3 feet. The feet unit cancels with a foot unit. Now I'm currently in yards. I need to do one more to get to miles. Yards will be at the bottom for that reference pair, miles at the top. 1 mile, 1760, I look it up. Yards. Yard unit cancels. I am in miles correctly. Then I just calculate the number. And the numbers are multiply all the top, divide by all the bottom, Let's double check. 235 times 1 times 1 times 1, so that's nothing. Divided by 12, divided by 3, divided by 760. Oh, that's going to be tiny, isn't it? Of course, I didn't have a long distance, a long length, so in miles it's going to be quite tiny. Quite tiny. 0.0037, rounding to two significant decimals. And there we go. Fairly efficient, I'd say, but still showing an understanding of unit conversions and picking the right reference pair and putting them in the right order. And there's some stuff to do still. Nice middle ground. This is my preferred way. But of course, if you already have something that works and it's clear enough on paper, it shows your work, then stick to that. It's okay. This is not the only way. I'm not pretending that this is the only way at all. So let's go back to this. Soon people realize that, as much as we need to be thankful for the sort of British nations and their historical significance for getting us to where we are, these units aren't the most efficient. We have a decimal number system working in tens and hundreds and thousands. Why is 1 mile 1,760 yards? It makes no sense. It makes no sense. These things often happen when things develop slowly over many hundreds of years. Efficiency is not quite what people are looking for. So why not change it? Why not change it? So that is what people did. They came together and say, no, let's just make this as efficient as we can, working in tens and hundreds and powers of 10 seems to fit our number system better because that's how our number system works. So the international standard for the SI system uses that exact thing. Now, I'm not going to write them all, but uh, let's say it uses 1 meter unit and builds on that. Now, the meaning of exactly what 1 meter is, that changed over time as well. I'll show you a little blurb here. You look it up on Wikipedia, which is what I did. Originally, they used distance from the equator to the North Pole. Then they made an actual physical meter bar that was in a museum somewhere that people can go and say, this is exactly what a meter is. It's pretty good, but what if that bar gets lost, right? Then we're all kind of screwed. Then they changed it to radioactive substance and wavelengths. Then they changed it to what it is now, which is a fraction of, or the distance light can travel in this fraction of a second. And the speed of light is a constant. Regardless, we don't need to think about it like that, but somewhere someone needed to say, look, if you ever want to know exactly what it is, this is what it is. Because what if we lose that meter bar? What if we lose that stick? Right now with technology, it's impossible to lose. So we have this sense of this 1 meter. Then we can go up or down. Let's go, let's say up first. And we can say, well, 1 kilometer, if I have longer distances to travel, maybe thousands of meters, I can talk about kilometers instead, just for convenience. Then if I have something sort of in between, like hundreds of meters, in practice, we don't really care to be that that efficient. It's either in meters or in kilometers for practical use, but they wanted to be thorough and go to every power of 10. 100 meters is one hectometer. 10 meters is one decameter. These aren't often used because we don't really need them. We could talk in thousands fairly effectively. So it's either long distances or it's the standard unit, meter. Nothing in between really makes me uncomfortable, but technically it is there. Then on the other side, when I go smaller, I have, let's suppose, I want to go smaller, much, much smaller. I can go to a thousandth of a meter. The other way around, I have these little millimeter units, and a thousand of them fit into 1 meter. Here it does kind of make practical difference. If I talk about tenths, then I still have fractions, which I want to avoid, whereas on the long side, it doesn't really make that big a difference. So I have a slightly bigger unit, which is the centimeter unit, and 100 of them make up 1 meter. And then I have the less common decimeter. 10 of them make up 1 meter. Now it really depends on how you want to phrase this, how you want to make this table, right? With this a reference to 1 meter, I can of course link a centimeter to a millimeter. Like from this, I could say 1 centimeter is the same as 10 millimeters and all kinds of things in between. But this is one way the table could look. Now, if you look at in the book, I'll show you here. There are different ways to say that. You can do it in powers of 10, but I'd like to avoid fractions since I'm not going to naturally think in fractions. Instead of saying 1 centimeter is 100th of a meter, I'd rather intuitively say 100 centimeters is the same as a meter. Try and avoid the fractions when that uh, association or correspondence between meter and centimeter is exactly the same. Why speak in fractions when I can avoid it? Okay, so let's look at some examples here, but now this is designed to be efficient. This is designed to exploit the decimal system and its benefits, working in powers of 10. So we have exercise 11.1. And again, maybe I'm making too big a deal of this, but the biggest danger of teaching, one of the biggest dangers, is to not think about things thoroughly before you step in front of uh, a class or a student or something. Things I take for granted, like units and converting units, I never think about them until you have to teach them and suddenly like, ooh, how do I explain this? I don't know. So even simple things can become very tricky when you have to teach them to a certain audience. So now I'm just going to go straight to my sort of physics-based conversion strategy. Again, this is my way. You don't have to do it exactly like this if you already have experience. I want to go meters to kilometers. Well, I can do that right away, right? So my meter unit and my kilometer unit will be positioned like this so that the meter unit can cancel, and my answer will be in kilometers. What's the conversion pair? 1 kilometer is 1,000 meters. So then 50 over 1,000. Let's show it in the chat. Nice to see something sometimes. But another benefit of working in powers of 10 is that the calculation becomes simpler as well. Everything just becomes much simpler and much more consistent as I go up and down to different scales. of length measurement. There's a consistency. There's a factor of 10 every time. If I step up to kilometers, I know it's 1,000 times. Oopsie. It's 1,000 times bigger. If I step down to millimeters, it's 1,000 times smaller. There's a consistency that makes it easy to work with and think about. So these are hopefully quite straightforward. I start with 2 meters. I want to go meters to centimeters. Well, my table allows me to do that directly right there. And I can say, well, my reference pair needs to have meters and centimeters in this order so that meters can cancel and my answer will be in the right units that I want. 1 meter, 100 centimeters, so 2 meters, 200 centimeters. Now, of course, there's always someone that sits there thinking, of course it's 200 centimeters. Why did I have to write anything? Because at the very least, you have to convince me in a test that you know how to do it. Because little Timmy is not going to know. He has no experience. How do you explain it to him? So we're sort of in that middle ground. Like I want to show understanding, even though I might intuitively, based on my experience, know the answer very, very quickly and feel it's unnecessary to show any work. It's always necessary to show your work. At the very least, to get all your marks, at the very least. 5 millimeters. So I want to go millimeters to decimeters. I perhaps don't have a direct conversion in the table that I'm allowed to use. And asking Google doesn't show any work. So I need to maybe go based on the table. I'm sort of stuck with this, right? I have to link it to meters. So millimeters I can take to meters and then maybe to decimeters. Clumsy perhaps, but I'm sort of like in a test going to be stuck with a given table and I have to show that I understand how to do this. So not everything in the table, not everything that is possible will be in the table I'm allowed to use because we're trying to test if you understand how this works. So 1 meter was 1,000 millimeters. That gets me to meters. Then I can go down to decimeters, again, because of what I have in my table. I want meters to decimeters. Meters will have to cancel with this one, like millimeters canceled here. Decimeters over there. 1 meter, 10 decimeters. Look it up if you're not familiar with decimeters. We don't use decimeters very often. Now I'm in the right unit, and it's all just tens here, right? Makes it easy to work with and find an answer, but I'll show it so there's something to see. 5 times 10 divided by 1,000. And like I thought, 0.05. So the SI units and the system is designed to be as easy as possible, letting the conversion scale tens fit with our number system, which is based on tens. Just makes sense. It didn't make sense to the English long ago, but who knows? You know, we can't criticize them too much because we kind of needed them to get to where we are today at some point in history at least. All right. So now the fun thing is mixing these two. Mixing these two. So we need a link between the two systems. Now there are many. Let's just see two of the options. Technically, you can have any link between them, but we'll stick to two. Now, I'm doing them in a simpler way than being absolutely precise. Let's write them over here, maybe. Them over here. Why not? There's a small one and a large one that you may see in your test. 1 mile corresponds to 1.6 kilometers. 1 inch is going to correspond to 2.5 centimeters. Now, to those of you that may exist, this is not necessarily precise. I think in reality it's 2.54 centimeters. But to be honest, if I do things just convert units for my personal interest or practical use, I don't need to be super precise. For me, it's perfectly okay to think of 2.5 centimeters and an inch being equivalent. I don't need to be correct to every decimal place when I just want to convert things for my own use. So I understand that these may not be exactly to the hundredth position correct, but this is how we would use it normally. So why not uh, have it match our needs? Okay. So don't lynch me for not saying 2.54. I'm doing it on purpose. All right, so now let's look at exercise 11.3, where we have to convert between two units. One is in the English system and one is in the SI system, one way or another. So now you'd have access to all of this, the linking conversions as well, and these, let's say, maybe not that one. Regardless, whatever you have available to you, that is what you are allowed to use. Could be a lot, could be very restrictive, because a part of the test is going to see if you can make this chain depending on the information available to you. So here I'm going to make a plan because I see in my table or tables, I don't have feet to meters right away, which is my goal. Feet to meters, nothing really. I have two options. Right? I can go the big way or the small way around to a meter. I can go up to miles. I'm starting in the English system, right? Feet. I can go up to miles and then down, then over to kilometers and then down to meters. Let's do plan A. Plan A. Let's take feet up to miles. Can I do that? Well, I'm going to have to go via yards. So feet to yards, yards to miles, miles to kilometers, kilometers to meters, and I'll be done. I'm not going to be scared of a long chain because it's just going to add more brackets. If I can do one bracket, I can do 5 brackets. What does that matter? Or I can go down to the smaller units. Go feet to inches, inches to centimeters, centimeters to meters. Now I'm not going to necessarily pick the smallest, the shortest chain here. Just pick whatever one you like, right? It really doesn't matter. I'm going to do both. I'll pick the top one. So now I want to pick feet and yards. Oops, my line went a little too far. I have to stretch this a little bit. Otherwise, we don't have enough to talk about. So let's take two options here. Feet at the bottom, yards at the top. 1 yard, 3 feet. Now I'm currently in yards. Now I need the yards and miles. That was the weird one that I may not have known. 1 mile is 1760 yards. Now I'm in miles. Then I go over to kilometers, miles and kilometers positioned like that. 1 mile, 1.6 kilometers. Now I'm in kilometers. Lastly, go to meters, kilometers at the bottom, meters at the top. 1 kilometer is 1,000 meters. Now I'm in meters and I'm done. Now, admittedly, remember our table that links the two systems may not be perfectly precise. So the two paths will not give me necessarily the exact same answer to the very last decimal digit. But because we've made that agreement, I will always accept both. So let's calculate that. Let's see here. 50 times 1.6 times 1,000 divided by 3 divided by 1760 equals. And we get 15.15-ish, right? I sort of have time. I want to do both. Let's do the B one. So now I have 50 feet. I want to go feet to inches. So that'll be 1 foot 12 inches. Now I'm currently in inches. Then I want to go inches and centimeters. So inches and centimeters. 1 inch, 2.5 centimeters. Understanding that that's the commonly used conversion. It's not scientifically precise, but that's okay. Then centimeters to meters. Just make sure your units cancel, right? So that you're ending up in the right unit. 1 meter is 100 centimeters. Let's see what we get here. Knowing it's not going to be exactly the same. Let's see. 50 times 12 times 2.5 divided by 100. So we get pretty close, right? Depends on what you're okay with pretty close meaning. I'll accept both, and it's because this conversion here is not perfectly accurate, our linking conversions, and that's okay. I've made that decision based on my goals and my needs, and I can live with that. Let's look at the Ooh, I have 3 more, but I only have 1 minute. Ooh. Let's perhaps do the following, because I know tomorrow's session is a little empty, a little sparse. What we're gonna do is, we have enough information. I would like you to try number 2, 3, and 4 before tomorrow's session. Then we will start with number 2, move into area, and then you can confirm where you are. Are you on track? Do you get how we do these things? Or are you missing something, and then we can help with that. So try number 2, 3, and 4. Since we're out of time today, it works out well, I think. We have more than enough time tomorrow. We're doing more of the same, just seeing how does the story change when I talk about area instead of length, and what does that mean. So try number 2, 3, and 4. See how that feels. We will do them tomorrow. And if I forget, let me know. I don't think I'll forget, but I probably will. And we'll just pick it up from there. But do get an idea of where you're at. Is it super easy? Great, you don't have to worry about it. Or is there something you need to practice? We want to know. We want to know. All right. Are there any questions or comments at this time? All right. Then we will continue this next time. Until then.